Hello and welcome to my course Getting Started with TypeScript Programming Language. My name is Fenil Jariwala and I am excited to be your instructor for this course. Well, if you are a web developer or mobile developer looking to take your skills to the next level, then you have come to the right place. In this course, we'll be exploring one of the most innovative and powerful programming languages of our time, TypeScript. Now you may be asking yourself, why TypeScript? Well, for starters, TypeScript is a superset of JavaScript that offers many benefits over the core JavaScript. With TypeScript, you can catch errors at compile time, write more organized and maintainable code, and take advantages of advanced features such as interfaces, class, and modules. But that's just the tip of the iceberg. In this course, we'll be diving into the many features and benefits of TypeScript and exploring how it can be used to build cleaner, more robust, and more scalable applications. Whether you are an experienced JavaScript developer looking forward to expand your skill set or a newcomer to TypeScript programming language looking for to get started on the right foot, this course is just right for you. I'll be covering everything from the basic of a TypeScript syntax, classes, and many more. So what are you waiting for? Let's dive in and start learning TypeScript today. I look forward to seeing you in this course. Now the question is, why to learn TypeScript? Today, I would like to talk about TypeScript and its benefits over other programming languages. TypeScript is a programming language that was introduced by Microsoft in 2012, and it has quickly become a popular choice for web developers. One of the primary benefits of TypeScript is that it is a strongly typed language. This means that the type of every variable, function, and parameter is explicitly defined. Strong typing helps to catch errors early in the development process and improve the overall quality and reliability of the code. Other programming languages such as JavaScript does not have this level of typing, which can lead to runtime errors that are difficult to debug. Another benefit of TypeScript is that it offers excellent tooling support. TypeScript is designed to work with modern development tools like Visual Studio Code, which provides intelligent code completion, debugging, and refactoring capabilities. These tools can help developers be more productive and write better code. TypeScript also has a feature called optional chaining, which allows developers to safely access properties of an object without risk of encountering a null or undefined value. This can save a lot of time and effort in writing code that would otherwise need to check for null or undefined values. In addition to these benefits, TypeScript also offers strong support for modern JavaScript features like arrow functions, async await, and modules. This means that the developers can take advantages of latest language features without sacrificing the benefit of strong typing and tooling support. To sum up, TypeScript offers many benefits over other programming languages, including strong typing, excellent tooling support, optional chaining, and support for modern JavaScript features. If you are a web developer, backend developer, I highly recommend giving TypeScript a try and see for yourself how it can improve the quality and the reliability of your code. During this course, we'll dive into the fundamental and indispensable concepts of TypeScript programming language. Our journey will commence with the comprehensive understanding of variable creation in TypeScript and the various methods available for doing so. Subsequently, we'll explore all the types present in TypeScript version 4.9, including but not limited to string, number, enum, union, interfaces, and types, and many more. Additionally, we'll cover essential control flow statements such as if-else, switch cases, loops. Finally, we'll dive into the critical knowledge of classes in the TypeScript. I am confident that this course will provide you with a solid foundation in TypeScript programming language and help you elevate your skills to the next level.
What is TypeScript? TypeScript is an open source programming language developed and maintained by Microsoft. It contains all of the JavaScript and then a bit more. And here, by a bit more, I mean type safety. Well, it's an open source, free, and strongly supported programming language by Microsoft. It is also called as a superset of the JavaScript. It adds additional features like static types, and that is optional, classes, module, interface, etc. to the JavaScript. The TypeScript was initially released to the public in October 2012 with the version 0.8, and the current version of the TypeScript is 4.9. Now let's see how things work in the TypeScript. So we write our programs into the TypeScript programming language, and the file extension for that is .ts. So what we do, we write our TypeScript into this code.ts file. Then we'll have the TypeScript compiler. What the TypeScript compiler will do, it will simply analyze our TypeScript code for the type checks. If there are no errors, it will convert our code.ts file to code.js file, and then we'll execute that code.js file. So that's how things work into the TypeScript. We write our code into the TypeScript files, we convert it to the JavaScript using our TypeScript compiler, and then we execute our JS files. Now a question may arise here. If at the end we are executing the JavaScript programs, then why we would write the TypeScript program, compile it down to JavaScript, and then execute the JavaScript program? Well, for that, you have to see the next lecture where I explain this answer programmatically. So I will see you in the next lecture.
It is my pleasure to welcome you all to the Getting Started with TypeScript language course on Udemy. I am delighted to have you here and to share my knowledge and expertise with you. As you all know, TypeScript is a powerful and widely used programming language that enables developers to build scalable, robust, and maintainable applications. It is a superset of JavaScript and provides additional features that make it easy to write code and catch errors early on the development process. In this course, you will learn the fundamentals of TypeScript, including its syntax, types, control flow statements, classes, and so on. You will also learn how to integrate TypeScript into your development workflow, how to write clean and maintainable code, and how to leverage TypeScript advanced features. Throughout this course, I encourage you to ask questions, participate in discussions, and engage with the material. Our goal is to create a supportive and collaborative learning environment where you can develop your skills and achieve your goals. I look forward to working with each and every one of you and helping you on your journey to become a skilled TypeScript developer. Thank you for choosing this course, and I wish you all the best in your learning journey. So let's get started.
Now before we move on, we need to set up our programming environment. For that, we are going to install some tools, and the first tool that we are going to use is the Visual Studio Code, and that is nothing but our code editor. So you can simply open your web browser and search for VS Code. Here you can simply click on this download link. Currently I am at the Windows, so I'm going to download the Visual Studio Code for the Windows. Well, if you are on the Ubuntu or the Mac, you can download the Visual Studio Code according to your operating system. I am simply going to click on this Windows, and that will start the downloading of the Visual Studio Code. Let me just skip this download process. Now the Visual Studio Code has been downloaded. Simply click on this up arrow, click on open, and that will start the installation of the Visual Studio Code. Here I have to select this I accept the agreement. I'll click on next. Well, if you want to create a desktop icon, you can check mark this. If you don't want to create one, keep it empty. I'll click on next, and I'll click on install. Now it will start the installation of the Visual Studio Code. Now the installation has been done. Make sure you select this Launch Visual Studio Code, click on Finish, and that will open the Visual Studio Code. Now we are done with the installation of the Visual Studio Code. Simply close it. Now open the new tab and search for the Node.js. Click on Node.js, and here to download for the Windows, you need to select this 18.14.2 LTS. That is nothing but the long time support. Make sure you select the LTS version of the Node.js. For the Ubuntu and the Mac users, I would recommend the same. Make sure you install the LTS version of the Node.js. I'll click on that, and that will start the downloading of the Node.js. Now once it's done, I'll click on this up arrow. I will click on Open when done, and that will start the setup wizard of the Node.js. Simply click on this Next, accept the terms, Next, Next, Next. You can leave this check mark empty, click on Next, click Install, and that will start the installation of the Node.js. Now a question may arise, why we need Node.js? Well, to execute JavaScript on our machine, we would need Node.js. Node.js is nothing but the environment that allows us to execute JavaScript on our machines. Our machines can't understand JavaScript, and to execute JavaScript on our machine, we need this Node.js environment. Now we can skip this installation process, and the installation has been done. I'll click on Finish. Now we have installed the Visual Studio Code and the Node.js. Now the following two steps are going to be optional for the Ubuntu and the Mac users, but for the Windows users, I would recommend you to follow along. I'll simply search for the Git Bash terminal. I'll click on this Downloads -git scm. As I said, this option and the upcoming option is going to be optional for the Ubuntu and the Mac users, so you can simply ignore this. For the Windows user, click on this Windows, and according to your operating system, you can download the standalone installer. At the moment, I am on the 64-bit machine, so I will simply click on this 64-bit Git for Windows setup, and that will start the downloading of the Git Bash terminal. Now a question may arise, why we need the Git Bash terminal? Well, first it provides us the Git utilities using CLI commands, and the second one is we can use the best kind of commands on our Windows. For that, I have installed this Git Bash terminal. I'll click on Open, and that will start the installation process. Simply click Yes, click Next, Next. Here it says that which editor would you like Git to use, and it is selected as use the Visual Studio Code as Git's default editor. If it's not selected, make sure you select this option, click on Next, and now here most of the time you have to click Next. So just go forward with the Next button, click Install, and that will start the installation of the Git Bash terminal. You can skip this installation process. Now the Git Bash has been installed. Make sure you uncheck this, click on Finish, and we have just installed our third tool, and the last tool is going to be the Windows terminal. Well, this option is only available for the Windows user. You can simply click on Windows and search for this Microsoft Store, and here you need to search for the Windows terminal. Simply type terminal, simply click on this Windows terminal, and here you need to click on this install, and that will start the downloading, and it will also install the Windows terminal on our machine. And the Windows terminal has been installed. I will simply click on this open. That will open the Windows terminal. Here, by default, the Windows terminal will open the Windows PowerShell profile. We have installed and configured the Git Bash terminal, and we are going to use Git Bash terminal in our Windows terminal to make use of the bash commands. I will simply click on this drop down. I will click on settings. Here in the startup, there is an option of selecting the default profile, and here default is Windows PowerShell. I will select the Git Bash. I will press save. Now when I open the new tab, you will see that it opens the Git Bash terminal. I will simply close this, close the settings. Now I guess we are done with the initial setup and setting up the programming environment. Now let's learn why we need TypeScript at the first place. So I'll see you in the next lecture. Now the question is, why TypeScript? So let's understand that through an example. Now I'm going to change my directory to the workspace directory. So at the moment, my workspace directory is in the C and in the workspace. While in this workspace directory, I'm going to save all the TypeScript projects. Here, I will create a new directory named ts-crash-course. To create a directory, you can simply use this mkdir command. You can simply type mkdir followed by the directory name. Now to create the directory, simply press enter, and now that will create this ts-crash-course directory. Now to change the directory to it, you can simply use the cd space directory name, and that is going to be ts-crash-course. Now we are into this ts-crash-course directory. Now to open this directory into the Visual Studio Code, you can simply type code space dot, and that will open this directory into the Visual Studio Code. Now let me just close this welcome, and that was the initial setup. Now the question still remains, why TypeScript? Now let's create a file named example.js. To create a file, you can simply click on this new file, and now you have to provide the name of the file, and that is going to be example.js. Simply create the file. Here I'm going to create a constant named message. To create a constant, you can simply type const followed by the variable name, and that is going to be message. Simply assign the value of hello world. Simply save it. Now we have the Visual Studio Code, but also we will need the formatter. Simply click on these extensions and simply search for prettier. Simply click on this prettier code formatter using prettier. Simply install it if you haven't installed it yet. And after installation process, simply open your example.js file, right click and click on this format document with. Here, click on this configure default formatter and simply select this prettier code formatter. Now our code will be formatted with the prettier. Now let's console this message. To console the message, you can simply type console.log and simply provide the message variable here. Now by consoling, it will print the value here in this message in the terminal. Now I will open the terminal, and here to execute the JavaScript file, we'll be using the Node.js. As I said before, our machines can't understand the JavaScript. To execute JavaScript on our machine, we'll need the Node.js. To do that, you can simply type node space. You need to provide the file name, and that is going to be example.js. Now, When you execute example.js, you will find the hello world. Now let me change the code. Add simple space, add a method of 2 lowercase. Simply save the file, execute it again, and now you will see that our string is converted lowercase. Now open the Visual Studio Code and now call this message like a function. Now simply save the file, and I want to notice a thing here. There are no errors shown here in this example.js file. Now let me execute this file. Simply type node example.js, and here it says that the type error message is not a function. Now I want you to notice a thing here. When we were writing this code, it didn't throw any warning like the code you are writing is not valid. It only threw an error in the runtime. Well, here is the catch of using the JavaScript. These kinds of error will be only shown in the runtime. Suppose you have an JS application running in the production and this kind of error appears out of nowhere in the runtime. It would be a very bad user experience. Now, to prevent such kind of runtime errors, or you can say bugs, you can use TypeScript. How? Here I'm going to create a new file named example.ts, and here what I will do, I will simply copy this code, paste it here. Only thing I will do is I will change the variable. Now to select the same string multiple times, you can simply press Ctrl or Command T, and I will change it to MSG. Now here I will save the file, and now when I hover over this message, it says that this expression is not callable. Type string has no call signature. Now let me split this example.ts and the example.js file. Let me close these files. Now here in our TypeScript, you can see these red underlines, and it's nothing but the errors. That's the difference between JavaScript and the TypeScript. When we were writing code in the JavaScript file, there were no errors shown, but here in the TypeScript, it is shown. What TypeScript does is, it simply checks your code for any type errors. If it finds any errors, it will throw them like this. And according to a report, TypeScript reduces 15% runtime bugs that a plain JavaScript program can produce in the runtime. Here, by writing the TypeScript, we are saving our debugging time, and also we are writing the quality JavaScript code. The main reason for using TypeScript, it simply provides us with the type safety. That means if you declare a variable as a string, then you can't assign any other value than string to it. With that, now we know why we need to use TypeScript over JavaScript. Now let's install the TypeScript compiler and initialize the TypeScript project. The TypeScript compiler is available as an npm package, which is also written in the TypeScript. Now to find that, you can simply search for npm, click on this www.npmjs.com, and here simply search for the TypeScript. Simply select this TypeScript and it will open this. Here is the basic information about this package. We are going to install this package as a global package. Installing a package globally allows you to use the code in the package as a set of tools on your local machine. You can simply copy this, npm install -g TypeScript. Here -g flag stands for global installation. Simply copy this, open your terminal and paste it here and press enter. That will install the TypeScript compiler as a global package. Now we can use this compiler anywhere on our machine. Well, if you are on Ubuntu or Mac and you are facing any issues related to e-access permission error, you might need to change the access rights. Now we have the TypeScript compiler ready. Now let's try to compile our example.ts file that you can see here. Now to compile this example.ts file, first thing you need to do is you have to be in the directory, and at the moment we are in the ts crash course directory where our example.ts file is. Now to compile the file you can simply use this tsc, and that is nothing but the command line utility for the TypeScript compiler. Now to compile it you can simply provide the file name. Let's say the file is going to be example.ts, press enter, and it throws an error of this expression is not callable. When you try to compile the TypeScript, now let me draw your attention to the example.js file. Here you can see that our previous code is gone. It is replaced with this. Now how did it happen? Our TypeScript compiler compiled our TypeScript to the JavaScript, but we know that there was an error during the compilation process. But still, why did the compiler compile the TypeScript to JavaScript? Well, the TypeScript compiler by default does not restrict the compilation process if there are any errors. Well, even if you have any errors, it will still compile your TypeScript to the JavaScript. Here, if you want to ask the compiler to only compile if there are no errors, you have to explicitly pass a flag of no emit on error. Now let me just undo our example.js file. Now here is the previous code. Now let me try to pass the no emit on error flag while compiling this example.ts file. I will simply add tsc, that is nothing but our TypeScript compiler. Now I will add the flag of -- no emit on error. Make sure you add this flag in the camel case. Now you have to provide the file name, and that is going to be example.ts. Press enter, and now it still throws an error, and that is correct. And now you will look at the example.js file, you will find that it is not changed. That means the compiler didn't compile the buggy TypeScript to the JavaScript. Now let's try to compile our TypeScript to the JavaScript. I'll simply remove this message and I'll simply add the log of printing this message. Now let's try to compile this. And here you can see that there are no errors shown in our example.ts file. I'll simply open the terminal. I'll type tsc -- no emit on error followed by the file name, and it compiled successfully. There were no errors shown. Now when I look at the example.js file, you will find the compiled TypeScript version. And here it says that the cannot redeclare block scoped variable message. And that happened because our example.ts file and the example.js file are both at the same level. This won't happen when we will be writing our TypeScript project. So basically, our TypeScript and the JavaScript files will reside in the different directory. This is happening because we are at the same level with the same file name and with the same variable names. So we'll fix that later for sure. So I guess we are done here. Now in the next lecture, let's set up the TypeScript configuration file. So I'll see you in the next lecture. Now let's make this project much more TypeScript compatible. For that, we are going to create a TypeScript configuration file named tsconfig.json. The question is how to do that. For that, simply open the terminal and simply type tsc space test init. When you do that, it creates the tsconfig.json file into our directory. Now let me open the VS Code, and you can simply close this example.js.ts and simply click on this tsconfig.json. Now that command created this tsconfig.json file. This file serves as the configuration to a TypeScript compiler. It tells the TypeScript compiler what to compile, where to output the JavaScript files, in which target, which module to target, and many more things. Now let's look at some of the fields. Here it says that it is nothing but the compiler options. Now let's look at the first section, and that is nothing but the languages and the environment. Here we can select the JavaScript language version for emitted JavaScript, and by default it is ES 2016 and we won't change it. Then comes the section of the modules, and the first field is module. It sets the module system for the program. You very likely want CommonJS for the Node.js projects. Here we'll use Node.js to execute the JavaScript files. That means whenever we create a TypeScript configuration file, we should know what is our target environment where the compiled JavaScript will be executed. According to that environment, we have to set this module property. CommonJS is used for the Node.js. We won't change it. If you want to execute your JavaScript into the browser, now instead of selecting here the CommonJS, you can select this ES6 or ES 2015. If your browser is much more older, you can simply select this ES 2015, and if it's the latest, you can select this ES6. Nowadays, most of the browsers support ES6 syntax. Since I'm on the Node.js, so I'll simply select this CommonJS option. After that comes this root directory. Now here we can specify the root folder for our TypeScript source files. So what I will do, I will create a new folder named src. I will uncomment this root directory, and here I will simply provide the src as the root directory of our TypeScript. Now there are any errors. It says that file example.ts is not under the root directory. The root directory is expected to contain all the source file. The file is in the program because match by default include pattern. Yeah, it says that we have this example.ts file outside our defined root directory. So what I'll do, I'll simply move my example.ts file inside the src, and also I will remove this example.js file. Now we have our example.js file inside the source directory. After that, we have this JavaScript support section. Well, if you want to allow the JavaScript along with the TypeScript, you can simply uncomment this. It is also marked as true. Also, if you want to enable error reporting in your JavaScript, you can simply uncomment this and mark it as a true. After that comes the section of the emit. Here, I'm going to uncomment this out directory. I will simply uncomment this, and here I'll simply provide the directory name, and that is dist. Now what do I mean by providing this dist into the out directory? That means our old TypeScript file resides in the source directory. Now when we'll execute, or you can say compile our TypeScript, that will be compiled into this dist directory. Also here, I'm going to enable this no emit on error flag. It will simply disable emitting the files if any type checking error are reported. Also, there are other options available, such as if you want to remove the comments from the compiled JavaScript, you can simply uncomment this and mark it as a true. If you want to create the source map files for the same, you can simply uncomment this and mark it as a true. Then comes the option of type checking. Well, here all the available options provided by TypeScript compiler. Here these are nothing but the TypeScript type checking options. Let's see some of them. The first one is no implicit any. Well, if you uncomment this and make it true, it will enable the error reporting for the expressions and the declarations for you define the type as any. So that will throw an error during the compilation. After that, there is a field of no unused locals, no unused parameters. If you uncomment this and mark it as true, it will throw an error if you have define any variable and haven't used it. Similar goes for the function parameters. If you define a function parameter and don't use it, the compiler will throw an error. Similar, we have this allow unused labels, allow unreachable code. So these are nothing but the type checking fields that you can enable according to your use case. Here we are going to enable the module detection flag. For that, I will search for module detection, and currently it says auto. I'll press Ctrl space and I will get these suggestions and I will select this force. It will ensure that every non-declaration file is treated as a module. If we don't set it to force, TypeScript compiler will throw errors when you define the same variable in different TypeScript files. So that's why I changed the module detection to force. So I guess we are done with the initial configuration of the tsconfig.json file, and we have enough knowledge about some of the fields of the tsconfig.json file. So now we have our tsconfig.json file. We also have our source directory. In that we have this example.ts file. Now let's try to compile this example.ts file. But before we do that, let me just change the name of this file to hello world. And that will be it. Now let's try to compile this. Now before we used our tsconfig.json file, what we used to do, we used to write this tsc followed by the file name, and that used to compile our TypeScript to the JavaScript. Now when we have our tsconfig.json file, we don't need to specify the file names. We just need to type tsc, press enter. Now here what it will do, it will look up for the configuration in this tsconfig.json file. It will see that we have this root directory as src, and in that we'll have our TypeScript files. That will be the output folder for all the emitted JavaScript files. Now we have our hello world.ts file, and in the dist we have this hello world.js file, and that is nothing but our compiled TypeScript to JavaScript. Let me just close the files, and you can see that this is our TypeScript file and this is our compiled TypeScript to the JavaScript. Now that was the first option. Now whenever we make changes, I want this TypeScript to compile automatically to the JavaScript. How to do that? For that, open the terminal, simply add tsc space -- watch. Now what it will do, it will start the compilation in the watch mode. That means now whenever you make changes into your TypeScript files and save the file, that will be compiled automatically by the compiler. So let's say I'll simply add s here, let's say hello worlds. Now when I save it, on the right side you will immediately see the changes of hello worlds, and that is compiled. Now let me just remove the worlds word. I will save the hello world.ts file, and on the right side you will see the instant changes in your JavaScript file. So that's the main difference between using the tsc and the tsc space -- watch command. Now we can compile our TypeScript to the JavaScript. Now let's see how we can define variables in the TypeScript. So I'll see you in the next lecture. Now let's learn how we can create variables in the TypeScript. For that, you can simply close this hello world.js file. Also you need to close this hello world.ts, close this tsconfig.json, open the Explorer, close this dist, and here in src you need to create a new directory named variables. And in the variables, I'm going to create a new file named var.ts. So basically, we can create variables in JavaScript or TypeScript three ways. First one is var, second one is let, and the third one is const. Now each of them has different use cases and features. Now let's understand the var and its limitations. Now to create a variable using var, you can simply type var followed by the message, or you can say the property name. So let's say I'm going to name this property as message. Now here you can assign the value. So let's say the value is going to be hello world. I'll simply save it, and after that I will console it. To console it, you can simply type console.log, and here you need to provide the property, and that's going to be message. Now by consoling, it will simply print the value of this message into the terminal. Now let me open the terminal, and here you can see that our compiler is running into the watch mode. That means it already compiled our var.js file to the JavaScript, and here you can see that. Now let me just close it. Now let me open another terminal. Now let me change the directory to dist. Change directory to variables because our var.js resides in the variables dist directory. Now let me just collapse the folders. Now let me try to execute this var.js file. To do that, you can simply type node followed by var.js, and that is nothing but a file name. And here it prints the hello world. Here I have defined this message variable as the global variable. That means you can access this message variable anywhere inside this file. Now there is a plus point of using the var variables. I am simply going to copy it and paste it here. Now I want you to note a thing. Here I defined the same variable with the same name 2 times. That means I redeclared the same variable with the same name, and it's just working fine. Now if I try to execute the node var.js, and you will see the hello world. Now let me just change the message here. Let's say simply add second initialization. Now I want you to note the output, and here you can see that the output is nothing but the second initialization. Now what it did, it simply redefined the message variable when you redeclared it. So you can say that this is one of the feature provided by var declarations. Now let me just add if block here. I will simply add if, and here I will simply pass the condition as true. Well, at the moment we don't know how to write the if else block. That we'll say later for sure, but for the sake of this example, I'm going to add a if clause followed by var, and I'm going to name this variable the message again. And here I will simply pass new message. Now when you write something inside the curly braces, the scope of that becomes limited to this curly braces. Now I want you to note a thing here. What is the expected behavior of the message? At the moment it's printing this second initialization. Now but when I console it again, it's going to print the new message. Now let's see that. I will simply add node var.js, and here you can see that it prints the new message. Now you may notice that this message is defined inside this if block, and its scope should be inside the if block only. Is there any bug here? Well, here what happened when we used the same variable declaration with the var, it redefined our message variable. Var variables can be redeclared and updated. That's why we got this output. Well, this is the problem using the var variables. If you use var in your code too much, in the long run, it may create such kind of issues. This will likely cause a lot of bugs in your code. Now, what is the solution? Now to overcome this kind of bugs, TypeScript introduced 2 new variable declaration ways, and they are let and const. Now I'm going to create a new file named let.ts inside the variables. So inside the variable, I will simply add let.ts. Now here, to create a variable using let, you can simply add let keyword followed by the property name, and that's going to be message. And here I'm simply going to assign the value of hey hi. And now we have created a variable using let. Now let me just console it, and for that I will simply add log, and in here I'll simply pass this message. Now I will execute this let.js file, and now you will see that it prints the hey hi. Now a question may arise when we are writing our TypeScript, how it's automatically compiling to the JavaScript. For that, we know that I'm running this TypeScript compiler in the watch mode. So whenever I'm making changes into our TypeScript file, it's going to be compiling our TypeScript to JavaScript behind the scenes. So now we have our let variable. Now let's try to redeclare the same variable. So let's say I'll simply copy and paste it here, and oops, there are red borders and it says that the cannot redeclare the block scoped variable message. Now let me just split the screen on the right, and I want you to compare the var declarations and the let variable declarations. In the var, you can see that we were able to redeclare the same message, but here in the let we can't do that. That is not possible, so we can't do that. Now let's try this if block here same way in the let. So let's say I will add the if block. I will pass the true condition, that means it will always be true, and it will execute the if block, and in that I will create a new message with the let variable declaration, and I will assign the value of, let's say, hey there. Now when we did the same thing in our var.ts file, we got the output of new message. Now we have done the same thing into our let.ts file. Now let's see what we get as an output. So let me just type node let.js, and now you can see that it prints hey hi. Well, that's the difference between var and the let. The let is block scoped. A block is a chunk of code bounded by the curly braces. A block lives in the curly braces. Anything within the curly braces is a block. So a variable declared in a block with let is only available inside the block. See, this is how let solves the problem created by this var variable declaration. Here, when you use the let variable declarations, you can simply update the value. So let's say if you want to update the value of this message, you can simply update the value. Now simply update the value, and there are no errors at the moment. Let me just execute that JS, and you will find the updated value inside our message variable. So when using let, you can reassign the value, and this is how you can do that. And that was same possible inside our message. So let's say here, if I say message updated value, now let me execute my var.ts file. Let's say var.js, and you will find the updated value. The reassignment of the value works in our var and the let, but it won't work in our const. So now let's see the const variable declaration in our next lecture. Now we know how we can declare variables using var and let. Now there is another way, and that is using const variable declaration. For that, I'm going to create a new file inside these variables. So let's say the file name is going to be const.ts. Now let me just bring it here. Now to create a variable using this const keyword, you can simply type const followed by the property name. Let's say the property is message, and the message that is going to be string, and that's going to be hey hi. So I'll simply save the file and I will console the message. So let's say console.log and message. Now let's try to execute this file. So let's say node const.js, and now we can say that it prints the hey hi. Now there is only one limitation of using the const variable. See, whenever you define a const variable, you have to initialize the value at that time. So let's say if I don't initialize the value, let's say if I keep it like this. Now when I hover over this message, it says that the const declarations must be initialized. Well, this won't be the case when we use the let variable declarations. So let's say if I remove the value here, let's say I'm going to remove this value. Well, it's not going to throw any problem because let allows that, but the constant, it always needs to be initialized at that time. Now let me copy and paste it here. Let me try to redeclare the same variable in the same scope, and it says that you cannot redeclare block scoped variable message. So that is the same approach that we followed in our let variable declaration, and it does not work in our let and const. So I'll simply remove that. Now let's try this if block thing. So I'll simply add if block here. As a condition, at the moment I will simply pass this true. That means this if block will always be executed. Now let me create another constant named message, and let's say the message is going to be hey there. Now let's see the output. Well, at the moment when I hover over it, it says that the message is declared but its value is never read. That means in const it's also going to be the block scope. Now let's execute our const.js file, and it prints the value as hey hi. That means now this constant message variable is scoped to this block. That means this value is not available outside this if block. Now the value it print that was available here as the global message variable, and it printed this hey hi. So I guess now you can understand how const and let solves this problem caused by var variable declarations. Well, let's see whether the reassignment works in the const variable declarations. So I'll simply add message, and I'll simply try to update the value like this. Now when I hover over it, it says that I cannot assign to message because it is a constant. That means you can't reassign a value to the constant variable. So you can't do that. So whenever you define a constant variable, make sure the value of that variable never changes. You just need to note that thing whenever you are using the const variable declarations. Now we have enough knowledge about how to declare variables using var, let and const. Now with that, we should know which types are available at the moment in the TypeScript. So now let's try to learn the different types available in the TypeScript. So I will see you in the next lecture. So the first type that we are going to learn is the string. For that, I'm going to create a directory named basic types inside our source directory. So inside our src, I'm going to create a new directory named basic types. And in that, I'm going to create a new file named string.ts. JavaScript has three very common used primitives: string, number, and boolean. Each has a corresponding type in the TypeScript. String represents the string values like hello world. Number is for numbers like 42 or 61. JavaScript does not have a special runtime value for integers. So there is no equivalent to int or float. Everything is simply number. Boolean is for the two values, true and false. Now let's see how we can define a string type variable. Now before we do that, you can simply close this var.ts, const.ts, and you can also close this let.ts. So I'm going to create a variable with the type of string. So let's say I will use the let variable declaration followed by the property name, and that's going to be first name. Now the question is how to assign the type here to the first name of string. For that, you can simply add colon followed by the string, and that is nothing but the type provided by the value. So let's say fennel. Now let me just console the first name, and now you can see that there are no errors shown at the moment. Now this is the way you can define the type in the TypeScript. First you have to declare the variable followed by colon followed by the type, and here this string is nothing but our type. Now in the terminal, first I have to go one directory up because at the moment I am in this variables directory. Now I am at the dist. Now I have to go into basic types. Now I can execute my string.js file and it prints the fennel. Now here we define the string data type for this first name. Now let's see. Let me add the description and let me simply assign the description here. Now let me just save it. Now when I hover over this first name, you will find the type of string. Now when I hover over the description, it says the type of string. Now you may notice one thing. We explicitly defined the string type for this first name, but we didn't do the same for the description. So how it's showing us the data type of string? Well, TypeScript does the magic here. TypeScript infers the type from the value. You can see that we passed the string as a data to this description variable, and TypeScript inferred the data type from the passed value. That means if I pass here number, so let's say I just passed here the number. Now when I hover over the description, the data type for the same is changed to number. So that's how TypeScript infers the type. Now there is a use case of backticks. So let me create a new variable using the let var declarations, and here I'll simply use the backticks. So let's say I will add the dollar followed by the curly braces, and in here I'll pass the first name. I'll simply cut the console log, paste it here, and I will change it to profile. Now let me try to execute this string.ts file, and here you can see that it prints I am fennel. Now how it's working? See, whenever you are using the backticks, you can dynamically pass a value to that particular string. So that's how you can do that using the backticks. Now that was all about string type. Now let's see the number. Now how you can define a number typed variable? So you can simply type let amount, and it's going to be the similar. Simply add a colon followed by number, and that is nothing but the type. Now you have to provide the value, and that's going to be 45. Now it's going to work similar. Now here there is one thing you need to note. I have defined this amount as a number. So let's say if I try to assign the value of string, it's going to throw an error of type string is not assignable to type number, because we know that we have defined this amount as a number, and when I try to assign the value of string to that amount, it should throw an error, and it is throwing an error of type string is not assignable to type number. Now this is how you can define the number type. Now let's see the boolean, and that's going to be very similar. Let's say I will create a let variable declaration with the is valid property. The type is going to be boolean, and the value is going to be true or false. So this is how you can define type for the string, number, and the boolean. Well, when you use type, it always comes pre-configured with some JavaScript methods. So let's say this profile has a type of string, and if I say profile dot, and you will find the list of available JavaScript methods, and let's say if I use this method of to lowercase, that will simply convert my string to the lowercase, and similarly it has the bunch of methods that you can execute. Now There is one thing you need to note. We have a string and a number constructor. Now, what is constructor here first of all? So let me create one. So let's say let me create variable with the name, and I will use this new keyword followed by the string where s is capital, and here I will simply pass the value of my name. Now what's the difference between this string and this string? Well, this string s with the small letter is nothing but the type, but with the string with s capital, that is nothing but the constructor. When you use string as a type here, it will be treated as the TypeScript type. Well, this is nothing but the different thing, it's string constructor. So make sure you don't use this capital S string as a type. Similarly, we have a number constructor. So let's say I will add new followed by this number constructor, and in here I will simply pass this number. So I guess now you can understand the difference between this type and this constructor. Well, constructor are nothing but the special methods of the classes that is invoked when you create an instance of that particular class. We'll see that later for sure, but I guess it was necessary for you to understand the difference between this number and this capital and number, this string type and this capital S string constructor. So now I guess we are done with this lecture. Now in the next lecture, we'll learn the type of array. So I will see you in the next lecture. Now we know how we can use array types to define the types for our array. Now let's learn how we can use an object type for defining the type for our objects. For that, I'll be creating a new file named object.ts inside the basic types directory. For that, I'll click on this new file. I will name the file as object.ts. And in here, I will create an employee object. So let's say I will use this let keyword followed by the property name, and that's going to be employee. And the type of that is going to be an object. Let me just save the file and let me console it. For that, I will simply use this employee. Now we have this employee, and it says that the variable employee is used before being assigned, because when I hover over the employee, the type of that is object, and currently it's an empty object. It doesn't have any value. So now we have to assign the value. So let's say I'll assign the value, and to assign the value to an object, I have to provide curly braces, and in that I have to provide the values as a key value pair based. So let's say the key is going to be the first name, and the value for that is going to be the name. So let's say first name colon, the name is going to be Fanil. Add comma if we want to add the multiple entries into an object. So let's say I want to have another key with the name of the last name with the surname. Also, I want to have the age of 25. Let's say I want to have the job title of web developer. Now when I try to console this employee object, it should not throw any error. So let's say note object, and now it says that it simply prints our object into the terminal. So this is how you can define an employee object using this object type, and this is how you can assign the values using key value pair based. Well, that's not it. If you want to access the particular value from this object, you can simply use this dot notation. You can simply type dot followed by first name. So let's say I have this first name, but before we do that, it says that the property first name does not exist on type object, because we have defined the type of this employee as an object. Currently, at this moment, we know that we have passed an object to this employee, but TypeScript is saying that you have defined the type of an object, so I don't know what first name is. Now, to overcome this problem, we are going to remove this object, and here I will simply add empty curly braces followed by the first name colon. Here I will provide the data type of string. Now here what I have done here, now I just removed the object type and I added an empty object with the name of first name, the type of string. That means now this employee object expects a key with the name of the first name, and it expects the value of that key to be the string. So let's say last name followed by string, age followed by number because age is going to be number, followed by title, and that's also going to be the string. Now when you look at this console, the error is gone. Now it says that yes, the first name is a property on this employee object. Now when we try to execute this object.js file, and here we will see that it prints the fennel. Well, that was the first way of accessing the value of the particular property in this employee object, and that was using this dot notation. Well, that is other way. You can simply provide the square brackets and single quotes, and here you can simply access each and every property from an object. So let's say I want to print the job title. Now when I node object.js file, it will print the web dev. Now here in the object, when we define a type for an object, there is a concept of optional parameter, or you can say the optional value. So let's say I want this job title to be an optional. To mark this type as an optional, you can simply add the question mark. Now when I hover over this employee, you will find that the first name, the type of the first name is string. Similar for the last name, the type of that is string, but for the job title, it has the type of string or undefined. That means now if I don't provide the value for this job title, it's not going to cause the problem. Now let me just console it, and it returns us the undefined. Now if I try to remove the value for this age, it's simply going to throw an error that property age is missing in the type because the age here is required. It's not undefined. Now let me just undo that. So this is how you can define these optional keys on the employee. Well, there also exists the concept of object destructuring. Now what is object destructuring? So let me just add a comment here. So let's say let me create a new constant. I will use the empty object and I will assign the value of employee. Now here I'll simply press Ctrl space and I will get this suggestion. So let's say first name. If I want to access only the first name of this employee object, I can use this destructuring. This is nothing but to call the destructuring. I can also use this way of employee.firstname, but if I want to access the particular property from an object and not destructure all of them, I can simply use this pattern. This is called the object destructuring. It's quite similar to this one. So let's say if I console the first name, I will press node space object.js and it will print undefined followed by first name because we don't have any job title at the moment, but we have the first name. So I guess that's it for this lecture. Now in the next lecture, let's learn the enum type. Now we know how we can use the string, number and the boolean type. Now let's learn how we can use the array type. For that, I'm going to create a new file inside the basic types. I'll simply add array.ts, and in here let's see how we can use the different array types to define the type for an array. So let's say here I want to have an array of fruits, and in that fruits array, I want to save the values of all the available fruits. So let's say I will create a new variable using this let keyword followed by the web property name. Let's say, let me just assign an empty array. Now by doing this, I just assign an empty array to this fruits. Now when I hover over this fruits, the type for that goes here like any followed by square brackets, and that means this fruit array can have any value. Now what if I want to define an array type for this fruit? I just want this fruit array to have the value of strings. To do that, you can simply add colon followed by string followed by square brackets. Now when I hover over these fruits, you will find the type of that is changed to string followed by the square brackets. Now this fruit can only have the array of strings. Now let me just, so let's say fruits dot, and here when you define a variable as an array, you would get this kind of JavaScript methods. All these methods can operate on this array. Now to push an item into this array, I'll be using this push method. So I'll simply add push and its method here, and here I have to provide the value. So let's say that's going to be watermelon. Now let me just save it and console the fruits. So let's say, now let me just console the array, and it says that it prints the watermelon. Now let me try to push another value inside this array. So let's say banana. Now let me try to console it, and it prints the array with the watermelon and the banana value. Now we know that we have defined an array of string type for these fruits. Now what if I try to push a value that is not string? So let's say fruits dot push, and in here let's say I try to push a value with the number. So let me just save it and let me check the console, and here it says that the argument type number is not assignable to the parameter type string, and it throws an error here. The fifth line where we have added fruits.push and we are passing the number 46. So that's what causing the problem, because we know that we can't push a number into the array of string, so this can't happen. Now that was one way of using this push method. Now there are other methods available on the array. So let's say if I want to pop, so let's say fruits.pop, that will remove topmost element from the array. So I'll simply console it. Now let me print it, and it says the watermelon. You will find that the banana is gone now. Now here we know that we defined an array of string type for the fruits. What if I want to have the mixed type array? Is that possible here in the TypeScript? Yes, it is. So I will create a new variable with the names of scores, and in here I will define the mixed type array here. For that, simply add colon, parenthesis, and in that I will provide the type. So let's say I want the score to have either the value of string or number, and it should be an array. So here what we have done, this score can have either the value of string or number inside an array. Now let me define a value here. So let's say this array can have either string or number. So let's say the first score is programming. I just added a string value. Now let me try to add the number, and it's working fine. Now if I try to add a value other than string or number, let's say I try to add the true, it throws a warning of type boolean is not assignable to type string or number. Now it's not going to work because we have defined this array to have the value of either string or number. This is also called as mixed type array. Now that was one way of defining the array type here. Now there is another way, and that is called the generic way. So let me just add a comment here. How to do that? For that, I'm going to create a new variable with the names of items. Here I will use this array followed by brackets, and in here I will provide the type, and that's going to be string. Now here, when I hover over the items, you would find the same type the way we used here in the fruits. Well, this is quite similar to what we have done here in the fruits type. It's quite similar, but this way is also called as the generic way. Now on the items, you can simply use your array methods such as push or pop or any array methods available. Now that was the second way. Now there is another way of creating an array, and that is using the array constructor. Well, we don't use the array constructor much often, but here for an example I am showing you this using array constructor. So I will simply add the comment of array constructor. So let's say to the fruits, I will assign the values using array constructor. For that, you can simply use this new keyword followed by this array, and in here we have to provide the values. So let's say apple followed by the banana. Make sure whenever you add a value inside this array constructor, you add it with the separated comma. Now you will find that it returns an array of string. Now let me console it here. So let's say, let me console the fruits. Let me execute the array.js file, and you will find that it returns us the apple and banana. Also on the fruits, when I simply add fruits dot, you will find these different array methods available. For an example, we have this length method that returns the current item length inside our array. Also we have this for each method. We'll have this entries, every, fill, filter, find, index, includes. So these are the methods available to perform on that array. So for the summary, we have two ways to define the type for an array. The first way would be to use this type followed by the square brackets, and the second way would be to use this generic way, but we won't be using this generic way too much. We'll be only using this simple way because it's easy for us to understand. And later we have this array constructor. We also won't be using this array constructor. So I guess that's it for this lecture. Now in our next lecture, we'll understand the object type. So I'll see you in the next lecture. What is an enum? An enum is a group of named constant values. Enum stands for enumerated type. To define an enum, you must follow these steps. First, use the enum keyword followed by the name of the enum. Then define the constant values for enum. Enums allow a developer to define a set of named constants. Using enums can make it easier to document the intent or create a set of distinct cases. TypeScript provides us both numeric and string-based enum. Now let's have a look at the numeric enums. An enum can be defined using the enum keyword, but for that, first, I'm going to create a new file with the name of enum.ts. And in here, to define an enum, I will simply add enum keyword followed by the enum name, and that's going to be direction. And here I will assign the constant values such as up, let's say 1, followed by down, followed by left, comma right. Now we have the direction enum. Above, we have a numeric enum where up is initialized with 1. All of the following members are auto-incremented from that point on. In other words, direction.up has the value 1, followed by down will have the value of 2, left will have the value of 3, followed by 4. If we wanted, we could leave off initializer entirely. If I remove this is equal to 1, now by default, the first constant is initialized with the value 0 followed by 1, 2 and 3. Now let's try to console this direction.up and let's see what it consoles. So let's say log, and in here I will simply use direction dot and I will get the suggestion of up. Now let me just execute my enum.js file, and now you can see that it returns the value of 0. Now let me initialize the up constant with the value 1. And now you will find that it returns the value as 1. Now let me try to console the value for this write. So let's say write. Now let me just save the file, execute node enum.js, and you will find the index for the write constant is 4. Now that was all about the numeric enums. So let me just add a comment here. Now we are going to understand the string enums. So let's say I have another enum with the same name, let's say direction, but before we do that I have to comment it out. I'll comment it, and in here I will add the up constant with the value of up. Now I'll simply copy it, paste it here. I'll press Ctrl or Command D to select the similar strings multiple times. Now I will change it to down. I'll simply copy and paste it here multiple times. I'll simply select Ctrl or Command D, change it to left. Similar I'll do for right. Now we have the string enum. Now let me just add the console. Let's say console.log followed by direction dot. Let me just print the value for this left. Now let me just execute this enum.js file, and in the console you will find the value for that. Well, if you notice a thing here, strings enum don't have auto incrementing behavior. So that is the main difference between string enums and the numeric enums. So I guess that's it for this lecture. Now in the next lecture, let's see the type of any. Now let's see the any type. For that, in our basic types, I'm going to create a new file named any.ts. So let me create an object here. So let's say object, and I'm going to assign the type of any here, and I will assign the value of x is going to have the value of, let's say, 0. Now when I hover over this object, it says that it has the type of any. That means now I can assign any value to this object. At the moment I have assigned this object. Later on, if I want to assign an array, string, number, boolean, anything, I can assign the value to this object. Now let's say, let me just try to call this foo method on this object. Now we know that this object is nothing but an object which has the value of x is equal to 0, and I'm trying to call this foo function on this object. Now when you define any variable as an object, it disables all TypeScript type checking. That means if I save this file, the compiler is not going to throw any errors. So I've just saved the file. Let me open the terminal, and you will find that it's not throwing any error because we have defined this object as any. But when we try to execute this any.js file, there it's going to cause the problem. So let's say node any.js, and here you will find that it throws an error of object.foo is not a function, and that is correct. So now let's say, let me just comment it. Let me just assign an error here. So this way you can assign any value to this object. So here by doing this, I just assign an error here. So let's say this value can also be the boolean, number, or string. So that's how things work when you use the any type. Well, in the TypeScript, it is not recommended to use the any type because if you use any type too much, there will be no difference between writing the TypeScript and the JavaScript, because we know that the JavaScript is dynamically typed and TypeScript is the static type. So if you use too much any in your TypeScript code, it's going to generate the bugs in the production. So I guess that's it for this lecture. Now let's learn how to store a fixed number of elements with the known types in the tuple. So I'll see you in the next lecture. Now let's understand the tuple in a TypeScript. For that, first I'm going to create a file inside this basic types. I'll create a new file named tuple.ts. Now question may arise, what is tuple? A tuple works like an array with some additional considerations. First one is the number of elements in the tuple is fixed, and the second thing is the type of elements are known and need not to be the same. So now I'm going to declare a tuple with the type. For that, I will create a new variable and the name of the property is going to be tuple. For the type, I will use colon followed by square brackets, and that is equal to an empty array. Now here in the type, I'm going to define the type. So let's say in the array, let's say the first one is going to be number followed by string followed by boolean. Now here what I have done, I have defined a tuple type for this tuple variable. Here it is an array, and in that array the first element is going to be the type of number, the second element is going to be the type of string, and the third element is going to be the type of boolean. Now let me assign the value here. So let's say it expects first element in this array to be the number. So let's say that number is here. Now the second parameter should be a string. So let's say hello world, and the third parameter should be the boolean. So let's say I'm going to assign the value of false. Now let me console it. Let me just add node tuple.js. So this is the way you can define the type for the particular tuple. As I said before, a tuple works like an array with some additional considerations. The number of elements in the tuples are fixed, and here you can see that the number of elements in this tuple are 3, and the data type need not to be the same. The first element is going to be the type of number followed by string and the boolean. Now here, if I try to change the value of the third element, so let's say the defined type for the third element is boolean. So let's say if here I pass a string, let's say I pass here the none, and you will find this warning, and it says that the type string is not assignable to the type boolean because tuple expects the exact type of the values that we have defined here in this array. So let me just undo that. Now here, since it is an array, you can access a value at particular index. So let's say I want to access the value at this particular index 1, and that's going to be the hello world. Now let me just console it, and you will find that it prints the hello world. Well, that's not it. That was the defining the tuple. Let me just add the comment here. Now the question is how to define the optional tuple elements. So let me just add a comment here. So let me create another variable named background color, and the type for that is going to be a tuple type, and that's going to be number followed by number followed by number. Now here I have defined this first 3 elements to be the type of number and the required. Now what if I want this 4th element to be an optional? For that, simply add the type followed by the question mark. Now that will mark this 4th element as an optional element. So let's say, now let me try to assign the value to this background tuple. So let's say 0 to 40. And now here you can see that I didn't assign the value to this fourth element, but still it's not throwing any error because we have defined this fourth element as an optional element. Now I'll copy it and paste it here. Now here, if I define the value for the fourth parameter, it's not going to cause any problem because it is an optional parameter. If you don't define any value here, and if you define a value, it's not going to cause any problem in both the cases. Now as a summary, we can say that a tuple is an array with a fixed number of elements whose types are known. Now we are done for this lecture. Now in the next lecture, we'll learn how we can use types in the functions. So I'll see you in the next lecture. TypeScript's type system allows you to build new types out of the existing ones using a large variety of operators. Now that we know how to write few types, it's time to start combining them in an interesting way. Now let's learn how to define a union type. The first way to combine these types you might see is a union type. A union type is a type from two or more other types, representing values that may be any of those types. We refer to each of these types as union's member. Now let's write a function that can operate on strings or number. For that, here in our basic types, I will create a new file with the name of union.ts. Here, I will simply create a new arrow function with the name of printId. So let's say I will add const followed by the function name, and that's going to be id, and that is going to be an arrow function. And this printId function is going to have a parameter of id, and this id is going to have the parameter of number or string. Now at the end, let me console it. So let's say your id is $ and provided the id. Now let me pass a number and a string to this print id. So let's say print id, and here you can see that this print id function expects id as a parameter, and the type of the id can be either string or number. So let's say first I'm going to pass the number as 121. Now let me try to execute this union.js file. So let's say node union.js file, and it prints the id of 121. After that, I'm going to use this method again, and in here I'm going to pass the string. So let's say some random string here. Now let me execute it union.js, and you can see that it prints both the number and the string. Now what if the data type of this id is string? I want to convert the string to the lowercase. How to do that? Is that possible here in the TypeScript? Yes. For that, we'll be using the type of operator. So let's say in our printId function, I'll simply add if-else block. For that, I'll select this if-else, and in here in the if block, I'll provide the condition of, let's say, type of. Select this type of operator. Here provide the parameter you want to check the type for, and in here simply add 3 times equal to, and here I will simply check if the type of the id is string. If the id is string, what I want to do, I will simply console and I will convert it to uppercase. Else if the id is number, because in the else case the id is always going to be the number. Now let me just pass like this, and now let me execute it, and now you will find that when we passed a number, it printed the same number, but when we passed a string, it converted to the uppercase. So this is how you can use the type of operator inside the TypeScript. Now we have enough information about how we can define different types in our TypeScript. Now let's see how we can use the type aliases and the interfaces. So now let's learn that in our upcoming lectures. So I will see you in the next lecture. Functions are the primary means of passing data around in the JavaScript. TypeScript allows you to specify the types of both the input and the output values of functions. Now here in the basic types, I'm going to create a new file with the name of function.ts. I'll close the files. I'll simply click on function.ts. I will click right click and I will select close others. The first concept that we are going to cover is parameter type annotations. So let me just comment it here. Now what do I mean by parameter type annotations? When you declare a function, you can add a type annotations after each parameter to declare what types of the parameter the function accepts. Parameter type annotations go after the parameter name. How to do that? So let's say I have a function with the name of grid. So let's say function. Now I have to provide the function name and that's going to be grid. And here this grid function accepts the name as a parameter. So let's say I'll pass the name and that is nothing but the parameter. Now the question is how to define a type for this name parameter. At the moment when I hover over this name, it says it's a parameter, but the data type for the same is any. Now to define a type for the name, that's going to be very similar. Let's say colon followed by string. Now when I hover over this name, you will find that its type is string. Now let me just console what we receive here. I will use the backticks followed by hello, comma, dollar, curly braces, and here I will simply add the name. Now we need to call this create method. How to do that? You can simply use greet, and in here you need to pass the value. Let's say if we don't pass a value here, let's say what it shows. It says that expected 1 argument but got 0. An argument for name was not provided because this name is required. Now if I make this name parameter an optional, to do that you can simply add the question mark. Now you'll find that the name parameter is an optional, but here we are going to keep it mandatory. So I'll simply pass my name here. Now let me execute this function.js file. And here you will see that it prints hello, fennel. Now that was all about the parameter type annotations. Well, that's not it. Here we passed a valid string. What if I try to pass the value that is not a string? So let's say I try to pass the number here, and currently it's not throwing any error. So let me just save it and let me check the terminal, and here it says that the argument type number is not assignable to parameter type string, and here it's causing the problem in the line 8 where we are passing 40 number to this greet method, and this greet method expects string as a parameter. So that's what it's causing the problem, so I'll simply remove that. Now the second concept comes is the return type annotation. So let's say, let me just add a comment here. Let's say I want to make sure a function always returns a number. How to do that? You can simply add another function with the name of get favorite number. Now a question may arise. We know how we can define the parameter type annotations here. Now how to define a return type annotations? For that, simply after this parenthesis call type number. Now here when I hover over this number, it says that a function whose declared type is neither void nor any must return a value. That means it's saying that currently we are not returning anything. We must return a number. So let's say return. Let me just return the number here. Now you will find that that error, or you can say the warning, is gone. So this is how you can define the return type annotations. Well, we have used normal JavaScript functions here. Well, in ES6 syntax, there is a support of arrow functions. How to do that? So let's say I want to write this greet function in an arrow function way. So how you can do that? For that, I'll simply comment this function. So I'll create a constant named const followed by the function name, and that's going to be greet. Here I have to provide the arrow function, and here this greet function accepts name as a parameter. So let's say name, and the type for that is going to be string. And here I'll simply console the message. I'll use the backticks hello comma dollar followed by curly braces, and the message is going to be name. Now let's see whether it's working or not. I will simply execute node space function.js, and it prints hello comma space fennel. Now our arrow function is working fine in the parameter type annotations. How to achieve the same into our return type annotations? So I'll simply comment it. I'll copy the function name. So let's say create a constant followed by an arrow function. Now after this parenthesis, you can simply provide the return type, and that's going to be the number. I will simply return to 23. Now you can see that our getFavNumber is an arrow function, and that returns the number. So that's how you can use your normal JavaScript functions and arrow functions in our parameter type annotations and return type annotations. Much like variable type annotations, you usually don't need a return type annotation because TypeScript will infer the function's return type based on its return statement. So what if I remove? Now before I remove that, I want to see the return type of this getFavNumber function, and it says the number. So now let me just remove this type. Now when I hover over it, you will find that it still says the number. Now what TypeScript did? TypeScript inferred the function's return type based on its return statement. The type annotation in above example doesn't change anything. So I guess that's it for this lecture. Now in the next lecture, let's learn the union type in the TypeScript. So I'll see you in the next lecture. We have been using object types and union types by writing them directly in type annotations. This is convenient, but it's common to want to use the same type more than once and refer to it by a single name. A type alias is exactly that, a name for any type. Now to learn that, first close this, and here in our basic types, I'll create a new file name type.ts. To define a type alias, you can simply use this type followed by the type name, and let's say I want my type to have the name of point, and the syntax is going to be quite similar to an object type. So let's say I want this point to have the key named x, and the data type for that is going to be number followed by y. The data type for the same is going to be the number. Now I'm going to assign this point type to the function parameter. So let me just create a new arrow function with the name of print code. Simply add an arrow function, and here take the first parameter as pt, that stands for point, and simply assign the type of point. Now here simply add the console. I'll simply use the backticks. X is going to be dollar curly braces pt dot x. I'll simply copy it and paste it here. I'll simply change it to y, and the value is going to be pt dot y. Now I will use this print code method, and in here you can see that the type of the parameter is expected as a point, and it is nothing but an object. When I press Ctrl space, and I will add an empty object and you will find these suggestions, and these suggestions are coming from this defining this point type here as a x. Let's say I want to pass 45. Let's say as a y I want to pass the 60. Now let me just save this file and let's try to execute this type.ts file. And here it prints the x and y. So this is how you can define the type aliases for the same. Now let's say I want this point to have the third point of z, and the condition is the z will be optional. How to define an optional field inside our type alias? So simply add z followed by question mark colon data type, and that's going to be number. So let's say here I will simply pass the z as a value 60. Here first we'll check whether the value for the z exists or not. So let's say if z is not equal to undefined, what we want to do here, it should be pt.z, because the data type for z you will find that it's either number or undefined. So here I'm simply checking if the z exists. What I want to do, I want to console the value of z2. So let's say I will change this y to z followed by z. I will try to execute this file, and here you will see that now if I remove the z from the passed parameter, you will find that it prints only x and y. So that's how you can pass the optional parameter to this type aliases. Well, there exists the concept of extending this type. How to do that? So let's say to extend the type from the point, you can simply define a new type named scale. Now to extend the type, you can simply use point and empty object, and in that you can add your new fields. So let's say I want this point to be named as m, and the data type for that is going to be number. Now when I hover over this scale, you will find that the type of the scale type alias is point and this added m. Now when I simply assign the type to this point constant, so let's say scale, and it's going to be an object, I will simply press Control space and I will get the suggestions. Now here I want to note a thing here. Here by doing this we extended the type of the point with this m, and here you are getting the suggestion of m, x, y and z. So this is how you can extend the type using AND operator followed by this empty object, and in that you can assign the property you want to extend with. So that's how you can extend a type in your type aliases. I will simply remove this. You can actually use the type alias to give a name to any type at all, not just an object type. For an example, a type alias can name a union type too. So let's say I will add a comment of union type alias. So let's say type is going to be id, and let's say the data type is going to be either number or string. So now when I hover over this id, you will find that this id type can be either number or string. So that's how types alias works in TypeScript. Now there is another way of declaring the types, and that is using interface. So let's learn interface in the next lecture. An interface declaration is another way to name an object type. Now here I'm going to create a new file with the name of interface.ts. Here in our interface.ts file, I'm going to copy this content. I'll copy it and paste it here, and the only thing that I'm going to change is I'm going to replace this type with the interface. So let's say interface, and I will remove this equal to. Now everything is going to work just fine. All we did is change the syntax. Now let me split the screen on the right. Well, These are the different syntaxes we need to follow while we are using the type aliases and the interface. When you use type aliases, you need to use type followed by the type name is equal to, and then we have to provide the object type. But when we use the interface, it itself is an object, and here we don't provide an equal to signature. Here we directly pass the fields with the data type. So now let's try to execute this interface.ts file. So let's say interface.js, and here you can see that it prints the x and y. Let me try to pass the z here. And let me try to execute it again, and you can see that it prints x, y, and z. Now a question may arise that what is the difference between type aliases and the interfaces? Well, type aliases and the interfaces are very similar. In many cases, you can choose between them freely. Almost all the features of an interface are available in the type. The key distinction is that a type cannot be reopened to add a new property versus an interface which always extendable. Here we saw an example of extending the type, but we were not able to add new fields into this point type alias. But here in our interface we can do that. How we can do that? So let's say here in this interface, what I will do, I will create a new interface with the same name, and I will add the new property with the name of m. Now here it shows the red border and it says that the property m is missing in the type x, y, z, but it's required in the type point. Now when I hover over the point, actually, okay, the m point is required. So this is not possible here in this type aliases. So let's say, let me just try it and let me show it to you. Let's say, let me just remove this and add it here, and it's going to throw an error of duplicate identifier point. So that's the only limitation of using type. You can't add a new field into this type aliases, but here using interface you can do that, and also the extending of the interface is possible. So here let's say, let me just pass the another field of m. That will make this error go away. Now let me type this interface. Now here is the interesting thing that I'm going to show you. Now let me just open basic types and interface.js file. Now I want you to compare the TypeScript version of this and the JavaScript version of this. Here in the TypeScript we strictly define our types, and here in the JavaScript you will find that there is no such type defined and even used into this JavaScript. So that is what the difference between the TypeScript and the JavaScript. Here a question may arise, what if this code produces a bug? Well, it's not going to produce a bug because you wrote your code into TypeScript, you compile it through the TypeScript compiler. The TypeScript compiler will only compile it to JavaScript only if your TypeScript code does not have any errors. Since we don't have any error, it's going to be compiled down to the JavaScript, and the compiled JavaScript is definitely going to work. So you don't need to worry about that. And here you can see that we define these interfaces, and that's completely removed here from the JavaScript file. So that's how things work into the TypeScript. I'll simply close it. I will select on collapse folder in Explorer. So I guess we are done for this lecture. Now in the next lecture, we'll learn the literals in the TypeScript. So I will see you in the next lecture. Now let's learn what is string literal and how we can use it. For that, I'm going to create a new file inside this basic types. So I will click here and I will create the new file named literal.ts. So let's say here I have a variable named alignment. Let me just add let and followed by the variable name, and that's going to be alignment. And let's say This variable can have the value of either left, right, or center. Now how to define that kind of type? Well, that is possible using string literals. How? So I'll simply add colon followed by the type, and that's going to be left. I will add the union followed by right, and that is nothing but another string literal followed by union and followed by another string literal, so let's say center. Now let me just save the file, and now when I hover over this alignment variable, you will find the type of left, right, and center. Now let me try to assign a value here. So let's say assignment is equal to, I will simply add a value, let's say, and when I press Ctrl space, I will get the suggestion of center, left, and right. So let me just assign here the center, and let me console it. For that, I will use this console.log. I will pass the variable of alignment. I'll save the file, and here we know that our compiler is running in the watch mode, so it's continuously compiling our TypeScript files whenever we are making some changes. So now we have our literal.js file inside the dist. So I'll go to dist followed by basic types, and in here I will execute the literal.js, and here it prints the center. Now let me try to assign the value that we haven't defined as a string literal. So let's say alignment equal to justify. Now when I save it and when I hover over it, you will find that the type justify is not assignable to type left, right, or center. So you can understand that we can only assign the value that we have defined here as a string literal. So this is how we can use the string literals in the TypeScript. So now we can say that a TypeScript string literal type define a type that accepts specified string literal. We can use the string literal types with the union types and type aliases to define types that accept a finite set of string literals, just the way we have used here in our alignment. So I guess that's it. Now in the next lecture, let's learn the control statements. So I'll see you in the next lecture. So now let's learn the control flow statements. Now the first control flow statement that we are going to learn is the if statement. For that, you can simply close this literal.ts file, and in here in the src, I'm going to create a new folder with the name of control flow. So let's say here in the src, I will add a new folder with the name of control flow. And I'm going to keep the camel case naming conventions. Now in the control flow, I'm going to add a new file with the name of if.ts. An if statement executes a statement based on a condition. If the condition is truthy, the if statement will execute the statements inside its body. So now let's learn how we can write a normal if statement. So let me just add a comment here. Let's say if statement. Now let's learn how we can write the if statement. For that, you can simply add if followed by the parenthesis. Well, here in this parenthesis, we'll add the condition followed by the curly braces. Well, this is nothing but the if body. So what do? We simply define our condition here in this parenthesis. If the condition is truthy, this body is going to be executed. So now I hope you can understand why this is called the control flow statement. So basically you can control the code execution based on the condition here. So now let's see a proper example where we can pass the condition and we can execute the if block. So let's say I will simply remove this, or yeah, let's just remove that. And in here, I'm going to create a new constant with the name of max. So let's say const followed by max, and I'm going to assign the value of 100. Here, I'm going to create a new variable using the let and the name of the variable is going to be counter, and the default value of the counter is going to be 0. Here I want to check if the counter value is less than maximum. What I want to do, I want to increase the counter by 1. So let's say in the if block, I'll simply add if. Here I have to provide the condition, and the condition is going to be counter. Here I will be simply checking if the counter is less than max. How to do that? You can simply add the arrow mark followed by the max. Now here, what we are doing, we are simply checking if the counter, and this suggests the less than, and if the counter is less than max, what we want to do, we want to increase the counter by 1. So here there are multiple ways you can increase the counter by 1. So let me just add the first way. So let's say you can simply add counter is equal to counter plus 1. Here what we are doing, we are simply incrementing the counter value by 1, and we are assigning the incremented counter to this counter variable. So that was the first way. Now let's see the other way. So let's say counter plus equal to 1. Well, this syntax is quite similar to this syntax in the line 6. Well, this is nothing but the shorthand for the syntax that we have written in the 6th line. So that was the second way. And the third way would be to do is you can simply add counter followed by plus plus operator. Now this is going to do the same thing. It's simply going to increment the counter by 1. So I'll keep that and I will remove that. Here I'm simply going to console the counter. So let's say counter. Now let's try to execute this if.js file. For that I have to go one directory up, and let me just list all the available directories. And now you can see that we have to move to the control flow directory. To do that you can simply add cd, and that is nothing but the change directory followed by control flow. Let me just list all the available files, and here I have this if.js file. So I can simply add node if.js, and now you can see that it prints the value 1. In this example, because the counter variable starts at 0, it is less than the maximum constant. The expression counter less than maximum evaluates to true. Therefore, the if statement executes the statement counter plus plus. Now let's initialize the counter variable at 100. Now let's try to execute this again. So let's say node if.js, and now we'll find that we got the value of 100. So now let's see what happened here. So you can see that our counter value is 100 and the maximum value is also 100. So this condition is false at the moment. So what happened? It didn't executed the counter plus plus. Therefore, the counter value remained 100. Well, if you want to execute other statements when the condition in the if statement evaluates to false, you can simply use the if-else statement. So let's say here, after if, you can simply add else followed by the curly braces, and in here what you can do, you can simply assign the value. So let's say counter is equal to 1. So here what I am doing, first I am checking if the counter value is less than maximum, I am incrementing the counter by 1, but if that condition is false, I am resetting the counter with the value 1. Now let's execute this. So let me just save it, and now let's execute this. So simply say node if.js, and you'll find a value of 1. So what happened here? This condition is false. It came to this else part, and then it resetted the counter value to 1, and we got the value 1 as an output. Well, in practice, if you have a simple condition, you can simply use the ternary operator rather than using this if-else statements. How you can do that? You can simply comment this, and here to add the ternary operator, first you have to add the condition. So let's say condition is going to be simple, let's say if the counter is less than max. Now to add the ternary operator, after the condition you have to add the question mark. And after the question mark, you have to add the logic that you want to execute if this condition is truthy. So let's say if this condition is true, I want to increment the counter by 1. So let's say counter plus plus followed by colon. Now after the colon, we have to add the logic that we want to execute when this condition is false. So let's say if this condition is false, what I want to do, I just want to reset the counter with the value 1. So now let me just save it and let's see what happens. Let me just add node if.js and here you will find the value of 1. So that was an example of using the ternary operator instead of if-else statement. Now let's see how we can use the if-else statement. See, when you want to execute code based on multiple conditions, you can use the if-else statement. The if-else statement can have one or more else-if branches, but the only one else branch. So let's say for an example, I'm going to comment this example and I'm going to keep it here for your reference. So after this, I'll simply add the discount variable. So let's say let discount with the type of number followed by, I will add the item count variable. So let's say item count and let's say the value of that is 11. Now here I'm going to add the if-else statement. So let's say first in the if statement, I simply want to check if the item count is greater than 0 and less than or equal to 5. If that condition is true, I want to provide the discount of 5%, followed by if the number of item is less than or equal to 10, I want to provide the discount of 10%. Now at the end, when the number of item is greater than 10, I want to provide the discount of 15%. So now let me add the if-else statement here. So I'll simply add if. Now here I'm going to provide the condition. So let's say if the item count is greater than 0, and to add the AND condition you can simply add and followed by item count, and that's going to be less than or equal to 5. Now we know how we can add the less than, but to provide the equal to, you have to add this equal to sign. Here simply provide the if block, and in here I will simply add the discount value of 5. So let's say if the item count is greater than 0 and less than or equal to 5, I want to provide the discount of 5%. Here now I want to add another condition, and where I want to check if the item count is greater than 5 and less than or equal to 10, I want to provide the discount of 10%. To do that, you can simply add else if, and in here you can simply provide the condition. I'll simply add the curly braces. Now I have to provide the condition. So let's say item count is greater than 5 and the item count is less than or equal to 10. At that moment, I want to provide the discount of 10%. Now in the else part, what I want to do, at the end, I want to provide the discount of 15%. So let's say if we have picked the item greater than 10, at that time we are going to provide the discount of 15. So let me just add console.log, and in here I'll simply provide the value of discount. Now let's execute this if.js file. Now here you will find that it output the 15 because we have provided the item count as 11. So now let me just pass here 7. So now I want to guess the output. So let's say it's going to be 10. So if I execute if.js file, I will get the output of 10. So that's how you can use the if else. This is the example of using the ternary operator in the if else Also here, this is the example of using if-else statement. So I guess that's it for this lecture. Now in the next lecture, let's learn another control flow statement, and that is switch case. So I'll see you in the next lecture. So now let's see how we can use loops in the TypeScript. For that, you can simply close this switch.ts file. Now in the control flow, I'm going to add a new file with the name of loops.ts. And in this file, I'm going to take an array of fruits that's going to have the multiple value of fruits. I will create a new constant with the name of fruits, and this fruits is going to have the value of array of strings. Now to define the type for that, I'll simply add string followed by square brackets, and let's say the value is going to be an array of strings. Watermelon, banana, mango. Now how to iterate over each and every item in this fruits array and print the value? Well, there are many ways available. First, we are going to see the use case of the for loop. So here, I will simply use the for loop. For that, I will add for followed by the parenthesis followed by the curly braces. Now here in this parenthesis, first we have to provide the initialization. Well, it is an expression evaluated once before the loop begins. Typically, we have to use this initialization to initialize the loop counter. So let's say here I will simply add let followed by index, and here I am going to initialize the index value with 0. So let's say I have initialized the index with the value 0. After that, I will add the semicolon. Now here we have to provide the condition. Well, this condition is an expression that is evaluated at the end of each loop iteration. If the condition is true, the statement in the loop body execute. So let's say the condition is going to be if the index is less than fruits dot length. So here what I want this loop to do, I just want this loop to iterate over the items in the fruit until it reaches the end of the array. Now after that, I have to provide the expression. Well, it is an expression that is evaluated before the condition is evaluated at the end of each loop iteration. Generally, we can use this expression to update the loop counter. So here I will simply add index plus plus. Now I will simply create a new constant with the name of fruit, and in here I will use this fruits array, and now I am going to fetch the value at particular index from this fruits array. For that, simply provide the square brackets provided by index. Now here what we are doing, first we are iterating over the fruits array with this index. Let's say the initial value of that is going to be 0, and we know that array always has the initial index as 0. So what it will do, it will pick the first item at the index 0, and that's going to be watermelon. Later it will check the condition. Let's say the index is going to be 0, so let's say 0 is less than 3, that means the condition is true. So what it will do, it will simply execute this. After that, it will simply increment the index by 1. After that, the index will become 1. Here it will simply check the condition. Let's say the condition is going to be 1 is less than 3, so that is condition is true. It will execute it. After, it will increment the index by 1. So let's say index will become 2. Now at this time the condition will be 2 is less than 3, so that means condition is true. So it will again move forward, it will execute the for loop body, and after that it will increment the index by 1. Now after that the index will become 3. Now what will be the condition? So let's say the condition is going to be 3 less than 3. Now this condition evaluates to false, so that means it will break off this for loop. So that's how thing is going to work in this for loop. Now let me just add the console log with this fruit. Now we can execute this loop. So let's say node loops.js, and now you'll find the value of all the fruits printed. So that was the first way of using this for loop. Well, there are other loops available too. So here I will simply add the for loop, and after that I will use the for off loop. Now here, when we use the for loop, we have to define the maximum length of this loop. We have to tell this loop that you have to execute this loop until this length. Now there is another loop where you don't have to define the length, and that is for off loop. So you can simply use this for off, and you can also select the syntax. Here I have to provide the iterator. So let's say the iterator is going to be fruit, and let's say the value, here they have said the object, but here you can also pass an array. So let's say the array is going to be fruits. Now here I will simply add the log. Now here I will simply log it, and now you can simply comment it. You can simply comment the for loop. Now when you execute it, you will find a similar output. What this loop is doing, it is simply iterating over each and every item from this fruits array. It is simply returning the iterator of this array, and we are just printing it here in the console. So that was the second way. Well, there are other loops available also in the JavaScript. So one of them is for each. So when you have an array, you can use the default for each loop provided on this array. So you can simply add fruits dot for each, and this is the loop that you can use. And here you have to provide the callback. So let's say here I'm going to provide an arrow function, and this arrow function is going to receive the value. Now in this arrow function, I'm simply going to console log the value. Now let me just save it, and let's see what it prints. Now when I execute it, you will find the similar value. So there are multiple ways you can iterate over an array, or you can use the for loop, for off loop, for each loop. Everything depends on the use case and the data you have. Here at the moment I have this array, so that's why I can use this for each loop, for off loop, and also the for loop. But if you have different use cases, for that you have to use according to your use cases. So I guess that's it for this lecture. Now in the next lecture, let's learn the while loop and the do while loop. So I will see you in the next lecture. Now let's learn the second control flow statement, and that is switch case. For that, in the control flow, I'm going to add another file with the name of switch.ts. And in that, now before explaining you the switch case, I'm going to add an example. After adding the example, I'm going to explain each and everything of how switch case works. So here I'm going to create a new variable with the name of target ID. Let's say the value of that is going to be button delete. To note that this example is only for the understanding. So let's say the value is going to be button delete. Now here I'm going to add the switch case. At the moment I'm just adding the switch case. Later I will explain the switch case in detail. So after adding the switch, I have to provide the parenthesis, and in the parenthesis I have to provide the expression. So let's say I'm going to pass the target ID followed by the curly braces. So what I have done here, I have just created the switch case. Now in that switch I have to provide the different cases. So let's say the first case is going to be button update followed by colon. Here I'll simply console the message of update. So let's say console.log followed by update, and after that I will add the break statement, and at the end I will add the default colon, simply add console, and in here I'm going to console not matched followed by break, and I'm going to copy this case, paste it again, and now I'm going to change the case, and that's going to be button delete. I'll update the message to delete followed by button new. I will change the console.log to new. Now let's try to understand how it works. First, the switch case statement evaluates the expression, and now I have passed the expression as target ID and it has the value of button delete. Then it searches for the first case clause whose expression evaluates to the same value, the value that we have passed as a target ID. And now when I select it, you will find that the second case matches the exact value that we have passed into the target ID. The switch case statement will execute the statement in the first case clause whose value matches. If no matching case clause is found, the switch case statement looks for the optional default clause. You can see that I have passed here the default clause. So let's say if the expression does not matches the cases that we have defined here, it will come to this default block and it will simply execute the code inside this default case. The break statement that associates with each and every case ensures that the control breaks out of the switch case statement once the statement in the case clause complete. If the matching case clause doesn't have a break statement, the program execution continues at the next statement in the switch case statement. By convention, the default clause is the last clause in the switch case statement. However, it doesn't need to be so. Now let's try to execute this switch.js file. So let me just add node followed by the file name, and that's going to be switch.js. Now when I execute it, it prints the delete. Here in this example, the target ID is set to button delete. The switch case statement compares the target ID with the list of values. Because the target ID matches the button delete, the statement in the corresponding case clause, it executes. So I guess that's it for the switch case. Now in the next lecture, let's learn the for loop. So I will see you in the next lecture. So in the previous lecture, we learned the different type of for loops available in the TypeScript. We learned the for loop, we learned for off loop, and also the for each loop. Now in this lecture, we are going to learn another two loops in the TypeScript, and that is while loop and the do while loop. So let's begin. For that, you can close this loops.ts file, and in here in the control flow, I'm going to create a new file with the name of do and do while. And I'm going to keep the camel case naming conventions. So let's say do and do while .ts. So now we have our do and do while .ts file, and we know that we are running our TypeScript compiler in the watch mode. So whenever we make changes, it's going to compile our TypeScript to the JavaScript. So first, let's learn the while loop. So I'll simply add a comment here. So let's say a while loop. The while statement allows you to create a loop that executes a block of code as long as the condition is true. So now let's see the syntax of the while loop. For that, you can simply add while followed by the parenthesis, and here in this parenthesis we are going to provide the condition followed by the curly braces, and this curly braces is going to be the loop body. Let me just add at the moment here true. So there is a thing you need to know before using the while loop. The while loop statement evaluates the condition before each loop iteration. If the condition evaluates to true, that means if this condition is true, the while statement executes the code from its code body. And if the condition is false, the execution continues with the statement after the while statement. Since the while statement evaluates the condition before its body is executed, a while loop is also called as a pretest loop. So now let's see the example of using the while loop. So let me just add here a counter. So let's say I will use the let followed by the counter, and I will initialize the counter variable with the value of 0. Here in the body, I will check for the condition. Let's say if the counter is less than 10, what I want to do, I want to console the counter. So what will be my condition? So let's say condition will be counter less than 10. So here I am simply checking if the counter is less than 10. What I want to do, I simply want to console the counter. So let's say console.log followed by the counter variable, and after that I'm going to increase the value of counter by 1. For that I will use counter plus plus. So here what's going to happen? Initially the counter value is going to be the 0, and the while loop evaluates the condition before executing the code body. And here what will be the counter value initially? So let's say the value is going to be 0, and 0 is less than 10. That means this condition evaluates to true. So it will execute the body, it will print the counter value, then we are incrementing the counter variable by 1. That means the counter value will become 1 and followed by this loop. Now let's try to execute this JS file. So let's say for that you can simply type node followed by 2 and 2while.js, and here you will find the value. Let me just make this terminal bigger, and here you will find the value of 2, 3, 4, 5. Now let me execute it again, and now you will find all the values. Since there was less space while consoling the output, it didn't print the 0 and 1. Now you can see. Now let me check it again, and you will find 0, 1, 2, 9. So let's say here if you want to explicitly break the loop for a condition, you can use the break statement. How to do that? So let's say here after body, what I want to do, if the counter value is greater than 7, I want to break this loop. How? For that I will add another if condition. Let's say if the counter value is greater than 7, here in the if body, what I will do, I will simply add the break statement. Now what this break statement will do? So let's see that in the execution. So I will simply execute it, and now you'll find the output. Now what this break statement did here, when the counter value became 8, it entered this if body part and it break the loop. It break this while loop. That means it stopped the execution of this while loop. So this is how you can use the break statement inside the while loop. And even if you want to use this break statement in this for loop, you can do that too. That is possible. Now let's learn the other loop, and that is do while loop. So let me make some space here. I will simply type clear. So now let's learn another loop, and that is do while loop. So now let's see the syntax of using the do while loop. Now let me just comment it, and here I will show you the syntax of the do while loop. Well, for that you simply add do followed by the curly braces, and this is going to be the loop body followed by the while followed by the condition. Here in this while we'll be adding our condition, and if that condition is true, we are going to execute the part inside this body. So let's see that by an example. I will simply remove that. Here I have a variable named index with the initialized value as 0. Here I will simply add 2 followed by console.log, and in here I will simply console the index, and after consoling the index I am going to increment the index value by 1. Now after adding the do part, I will add the while followed by the condition. So let's say if my index is less than 10, then and only I want to execute this do part. So let's say if the condition is less than 10, we want to execute this do part. So now let's see what happens here. So let me just type node followed by 2 and do while loop. So let me just make it bigger so you can see it clearly. And here we have, let me execute it again, and I will find that here we have the same output with value 0 to 9. Now there are some things you need to note here. The do while statement executes statement in its body surrounded by the curly braces until this condition is false. The do while statement always executes its loop body at least once. Unlike the while statement, the do while statement evaluates the condition after each loop iteration. Therefore, it is also called as a post-test loop. And here we saw an example of using the while loop and the do while loop. Here I said the do while statement always executes its loop body at least once. Now what do I mean by that? So let's say here in this file, I'll simply add the false. Now here, by providing the false, it should not evaluate this body part. So let's say, now let me just try to execute this to and do while.js file. And here you will find it prints the 0. That means this do part is always being executed at least once, whether the condition is true or false. Well, that is the main difference between using the do while and the while loop. Well, that was the difference here. Let me just uncomment this, and here, while using the while loop, we know that we are checking the condition before executing the body part, but that's not the same case here in the do while loop. First, we initially execute the body part, followed by we check the condition. If the condition is true, then we follow the further iterations. So that's the main difference between the while loop and the do while loop. So now we know a lot of things about TypeScript. We know how we can use TypeScript types. We know how we can define variables using let, const and var, and what are the differences between using let, const and var. Also, we have used the control flow statements to control the code execution based on the specific condition. Now let's see how we can use the default parameters and optional parameters in the functions. So for that, I'm going to close this to and do while.ts followed by loops.ts. Now here in the src, I'm going to create a new folder with the name of functions. So let's say functions, and here in this functions, the first file that I'm going to create is the default param. So let's say default param.ts. So here we are going to learn how we can use functions and how we can pass the default value to the parameter in the function. So here in the JavaScript, or you can say in the TypeScript, you can define a function in two ways. So first way would be to use the normal function. So let's say I'll simply use the function followed by the function name. So let's say my function name is going to be an apply discount. So let's say apply discount parenthesis followed by the function body, and now to call this function you can simply type apply discount, and here this apply discount function is going to have two parameters. So let's say the first parameter is going to be the price and the second parameter is going to be the applied discount. The parameter is going to be price, and to add a type for this price you can simply add colon followed by number. So here what we have done, we have used our applied discount function and we have assigned a parameter and the type of the same is going to be number. And now when I hover over this function calling, you will find this error of an argument for price was not provided, because here this price is required. We have to pass a value here. We'll do that later for sure. So let's say the second parameter is going to be discount, and here I'm going to assign a default value as 0.08. Now here what I have done, I have just passed this default value for this discount value. Now here I'm simply going to return the price. So let's say return followed by price,